91, sketch a bell curve, then compute the z-score for 24. And number 2, compute 3 factorial divided by 5 factorial. Share with your neighbors, see what you got. And let me get a code for you to send me your warm-up. All right, agenda, warm-up number 91, conditional probability, 8 problems only. And today, in regards to the conditional probability where we're at, we're going into more counting rules. Now we're going to get to the funner part of the of this section in regards to probability. And for some of you, it's probably going to be a fun experience. How about them apples, yeah? All right. So, get a Cornell note ready, please, so we can get started with that. Code for your home plate for tonight, JIWVU, JIWVU, JIWVU. All right, so our objective for today is identify and compute problems with the fundamental counting rule, Today we're going to touch upon that. I'm going to show you some examples. Hopefully after we do several examples, you should be able to come up with a definition for fundamental counting rule. And it's fairly simple. This rule is straightforward. But the following ones, the ones that we're going to get into tomorrow and the next one, are the ones that might give you a little bit of challenge. Let's just call it that, a little bit of challenge. All right, so fundamental counting rule. So let's see where we've been so far. We've covered probability, classical, empirical, and subjective, yes? And we're getting now into counting rules. And here goes the flow. Write this down. We're starting with fundamental counting rule. From there, we're going to permutation rules. And then from there, we're going to combination rules. So write that little diagram there so that you know the roadmap that we're going to take. Here we go. So, fundamental counting rule. First, let me elaborate on showing you an example first. Then we're going to do a second example. And then from there, we're going to come up with a rule of what fundamental counting rule is. So look up to the screen, writing utensils down, and it reads, a coin is tossed and a die is rolled. Find the number of outcomes for the sequence of events. So think about it. Coin is tossed. A die is rolled. How many total outcomes would we get? Talk it over to your neighbor. If we flip a coin and then roll a die. Talk it over to your neighbor. How many total outcomes do we get? Talk it over to your neighbor. We've done this one before, by the way. I just want to see if you remember. Looks like Jaden's got it. Very good, Jaden. Joel's got it. Very good, Joel. Coin is tossed, and a die is rolled. All right. So, I'm not going to put you on the spot, being that it's Monday. But here goes the diagram. Look up. Coin, how many outcomes? 2. Is that correct? Heads or tails? How about the die? If we roll it, how many total outcomes? 6 for the heads and 6 for the tails. So how many total outcomes, guys? 12. That is correct. So copy on your paper example 1. Don't copy the tree diagram. I'm just showing you where we're headed with this. But copy the actual problem. Example 1, a coin is tossed and a die is rolled. Find the number of outcomes of the sequence of events. And right there, write 12. Okay? All right. So we wrote for this one 12 outcomes. 12 outcomes. Okay. So how many outcomes did we say they were for the coin? 2. How about for the die? 6. Do you see the relation? Tell your neighbor the relation for this to the total outcomes. Does everybody see it? Yes? Okay. All right. So, example 2. It says, there are 4 blood types. Think about that one. A, B, AB, and O. So there's 4 of them. Blood can also be labeled Rh positive or Rh negative. That's the second. Finally, a donor can be classified as male or female. Ooh, this one's building up really quick. Let me go back to the one we just did really quick. This one was just a die and a coin. So how many? 2 of them. 2 different set of outcomes, right? Outcome for the coins and outcome for the die. Okay. But for this one, we got A, B, AB, and O. Then we got Rh positive, Rh negative, and then the last branches would be what? Male or female. So let's think. How many different ways can a donor have his or her blood labeled? So check this out. I'm going to underline stuff. That's one set. Second set. And third set. Picture the tree diagram as it builds. Talk it over your neighbor. According to what we did over here, how many total outcomes do we have for that one? Talk it over your neighbor. Let's see if they can look at it. By now they catch it. Fundamental counting rule. Looks like Jaden's got it. Diego's got it. All right, Diego. Especially since everybody put away their AirPods. All right. Diego, how many different outcomes for the blood types? 4. Okay. And then what other classification do we have over here? How many? And then at the end, classification also by what? Which is? Therefore, tell your neighbor the total number of outcomes. Caleb, what do you think? Hands, if you got that? That is correct. Copy that one, please, on your paper, and I'm going to show you the tree diagram in a little bit. And basically, all we're using is the fundamental counting rule. Fundamental counting rule, yes. No, if you just want to write 4 blood types, A, B, AB, and O, and then comma, RH plus, RH negative, and then at the end, male and female, that's fine. All right, as you're finishing copying that, let me show you the tree diagram for that situation. Look up. We got A, B, AB, and O. For A, it can be classified as what? RH plus or RH positive, RH negative. And of course, for RH positive, it can be male, female. Same thing for RH negative, male and female. So therefore, once you start listing all your outcomes, we said it would be a total of what? 16. So if you count all these, it should be a total of 16. From 1 to 5, how comfortable are you so far with that? Okay. So I'm going to give you now one for you to do by yourself. Let's see how you do. But it's got more stuff than that. Okay? Of course. Example number 3. It reads, a paint manufacturer wishes to manufacture several different paints. The categories include color, red, blue, white, black, green, brown, yellow. Type of paint could be latex or oil. Texture could be flat, semi-gloss that it's a little shiny, or high gloss which is very shiny. Or it could be for indoor or outdoor. And by the way, those are very true situations. Whenever you will own your home and when you go shopping for paint, they're going to ask you all those questions. So therefore, look at all the different options, and then it says, how many different kinds of paint can be made if you can select one color, one type, one texture, and one use? So, first copy the problem, and then talk it over to your neighbor and see what you come up with. Go. All right. Once again, a manufacturer could be, you guys know that we have a store here for Sherwin-Williams, right? That paint store over here by the fairgrounds in the backside. There's that store. They have all that. Lowe's can probably use that. Home Depot, Walmart. So with that said, who went last? Diego? Oh, Jaden? Jaden, pass the one. Oh, you haven't gone? Okay. Oh, wait. Wasn't it Caleb the last one? Caleb, pass them one. Jaden, let's go. How many different kinds of paint can be made if you can select one of each of the options? What is it? 84. How'd you come up with that? So give me numbers first. Let's see. 2. But how many different options do we have? Very good. 7. So 7 colors. What else? And that's 84. All right, hands if you got that. Looks about right. That is correct. That's what we call the fundamental counting rule. We look at the options, and then what do we do? Okay, so let me go back to the previous ones. We started with a simple one, which was a coin and a die. And then they asked how many total outcomes? 12. From there, we went to this one, blood type, another blood type, and then classification for male or female. And then we said that this was 16. Then at the end, we came up with this problem with paint, 7 different colors, types, texture, and use. That gives us 84. Okay, so with that said, you know what, before we get to the rules, send me your notes really quick. Hold on. All right, so as you're sending me that, I'm going to give you one more just to solidize the rule. So start thinking. Fundamental counting rule is, I've been using it so far for these 3 examples. Here goes the 4th example. And it reads, the manager of department store chain wishes to make a 4-digit identification card for her employees. So an ID with how many digits? 4. So picture that. So here's the ID, and then each ID should have 4 digits. Are we there so far? Okay. How many different cards can be made if she uses digits 1, 2, 3, 4, 5, and 6, and repetitions are permitted? So talk it with your neighbor, let them know how many different numbers do we use for each of these slots and the ID. And then from there, how many total IDs can come up with that? Talk it over your neighbor. Go. All right. So, Jaden, pass them on. Caleb, what shall we do? 6 times 4. Six plus 6. Hands if you agree with that. Close, very close. Pass someone, Caleb. Jaden? That is correct. Multiplication instead of addition. There's 6 options for the first slot, second slot, third, and fourth. Compute that and give me the total amount of IDs that we can come up with given that combination. Write that down, please. All right. You guys need more time? All right, let's see. Peyton, pass someone. Chelsea, fundamental counting rule. What would you tell someone it is? Find all data. Okay, hold on, don't write this down, but let's sift this through. Find all data. What does that mean? Like, okay, so find all data and problem, okay? And then multiply what? Okay, good start. Pass someone. Outcomes of each event to get total amount of outcomes. That is correct. Write that down, please. Multiply outcomes for each event to get a total number of outcomes. Woo-wee. And the way they present it in the rules, it looks like this: K sub 1 times K sub 2, K sub 3, dot, 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 K sub n. N being the nth number of events. From 1 to 5, how comfortable are you so far with that? 4, 5, 4, 5. Yeah, we got this, right? All right. However, I already introduced on the warm-ups another rule, and I haven't really formally introduced it to you guys, but here it goes. And that rule is known the factorial rule. Factorial rule. And it looks like, my goodness, why? It bugs. Factorial rule. For any counting n, n factorial is equal to n times n minus 1 times n minus 2, dot, 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 all the way to 1. Copy that. Factorial rule. For example, if n is 7, this says that when n factorial being 7 factorial is the same as 7 times 6 times 5 times 4 times 3 times 2, all the way to get to 1. That's what this says. The other thing to remember, whenever you see a 0 factorial, that is always equal to 1. 0 factorial is equal to 1. Once again, the problem is the same as the one we just did with the manager. Same thing. The question is different, though. How many different cards can be made if she uses digits 1, 2, 3, 4, 5, and 6, but repetitions are not permitted? Four slots, 1, 2, 3, 4. Repetitions are not permitted. All right. Who went last? Daisy? Pass on one, Daisy. Mia, Victoria. What would you write? Five. Okay, technically she is correct, right? This, we can write it as what? 6 factorial, is that correct? However, how many slots does the ID badge have? 4. So that means the first slot should have up to how many? 6 numbers. How about the second slot? And that's it, is that correct? Therefore, total number of IDs is 360. Does everybody see what we're doing? Yes? From 1 to 5, I'm comfortable are you with this? Factorial? Yeah, just follow it with no repetition. So this is going to work anytime when they say repetitions are not permitted or no repetitions of numbers. Okay? So, with that said, I'm going to stop right there. I was going to give you a couple more for practice, but I think we got it. But here's your home play for tonight. You already copied the code on the screen. So for those of you that are following on YouTube, you can go to the code I gave you at the beginning and get the practice in for those problems. All right? A good one. Enjoy. Enjoy your home play. See you guys tomorrow. Bye.